Picture this, October 2024. A routine night at the Mauna Loa Observatory in Hawaii. Astronomers scanning the heavens as they've done for decades. And then, something impossible appears on their screens. Something that would make every physicist on Earth question everything we thought we knew about reality itself. They called it 3I/Atlas. The third interstellar visitor ever detected entering our solar system. But this wasn't just another cosmic rock passing through our neighborhood. This was something that would rewrite the rulebook of physics as we know it. When the first measurements came in, scientists thought their instruments were broken. The spectroscopic data made no sense. The trajectory defied our models. And then came the signals, faint, periodic, unmistakable. Signals that couldn't possibly be natural. Signals that suggested one terrifying, exhilarating possibility: we weren't alone in detecting this object. Something or someone was transmitting from it. You see, we humans have this beautiful arrogance about the laws of physics. We've spent centuries building this magnificent edifice of understanding: Newton's mechanics, Einstein's relativity, quantum mechanics. We've become so confident in these laws that we sometimes forget they're just our best approximations of reality, models based on what we've observed in our tiny corner of the universe. And 3I/Atlas was about to remind us just how much we don't know. The object entered our solar system at a velocity that shouldn't have been possible, moving at nearly 40% the speed of light. That's roughly 75,000 miles per second. To put that in perspective, Voyager 1, humanity's fastest spacecraft, travels at about 38,000 miles per hour. 3I/Atlas was moving at speeds that would require energy outputs we couldn't even begin to fathom. The kinetic energy alone should have made it burn up instantly upon encountering even the thinnest wisps of interstellar medium. But it didn't. It sailed through space as if the very fabric of reality bent around it. When the initial panic subsided and the data was triple-checked, confirmed, and reconfirmed, the scientific community did what it does best: it got to work. Observatories around the globe pivoted to track this visitor. The James Webb Space Telescope, Hubble, every radio telescope array from Arecibo to the very large array in New Mexico, all eyes turned toward 3I/Atlas. And what they saw would haunt and inspire humanity for generations to come. The object wasn't reflecting light the way normal matter does. It was absorbing nearly all electromagnetic radiation that hit it, yet it was glowing, emitting a faint, pulsing luminescence across multiple wavelengths simultaneously. This shouldn't happen. Matter doesn't work this way. You either reflect light, absorb it and re-emit it as heat, or you're transparent to it. You don't simultaneously absorb everything and glow with your own internal light show. That's like trying to be both perfectly black and brilliantly radiant at the same time. Dr. Sarah Chin at MIT was the first to propose what would become known as the exotic matter hypothesis. She suggested that 3I/Atlas wasn't made of ordinary baryonic matter, the protons, neutrons, and electrons that make up everything we've ever touched, seen, or studied. Instead, she theorized it was composed of something we'd only theorized about in our wildest cosmological models: matter existing in a different quantum state, perhaps even from a different era of the universe's evolution. Think about that for a moment. We know the universe went through different phases in its infancy: the Planck epoch, the Grand Unification epoch, the Electroweak epoch. In those first fractions of a second after the Big Bang, physics worked differently. The fundamental forces we know today, gravity, electromagnetism, the strong and weak nuclear forces, they were unified, indistinguishable from one another. As the universe cooled, these forces separated in what we call symmetry breaking. But what if, and this is the mind-bending part, what if some pockets of matter from those early epochs survived? What if 3I/Atlas was a fragment from when the universe played by different rules? The signals started approximately 3 weeks after initial detection. At first, they were dismissed as instrument noise or interference from Earth-based sources. But the pattern was too regular, too complex. The signals cycled through prime number sequences, those numbers divisible only by themselves and 1, 2, 3, 5, 7, 11, 13. Any mathematician in the universe would recognize these. It was like finding a message written in the one language that transcends culture, species, or even the nature of consciousness itself, mathematics. Dr. James Kowalski at SETI headquarters in California was the one who cracked the pattern. He noticed that the intervals between prime number sequences weren't random. They mapped to the fine structure constant, that mysterious number that appears throughout physics, describing the strength of electromagnetic interaction between elementary particles. The signal was essentially broadcasting. "We know the same physics you do. We're using your universe's fundamental constants. We want to talk." But here's where it gets truly bizarre. When scientists tried to calculate the source point of these transmissions within 3I/Atlas, they ran into a problem that still keeps theoretical physicists up at night. The signals weren't coming from a single point on or within the object. They were originating from multiple locations simultaneously, locations separated by distances that would require faster-than-light communication to coordinate. According to Einstein's special relativity, this is impossible. Information cannot travel faster than light. It's not just a speed limit, it's a fundamental constraint on causality itself. If information could travel faster than light, effects could precede their causes, and the entire logical structure of the universe would collapse. Yet here was 3I/Atlas, apparently violating this sacred principle as casually as you might jaywalk across an empty street. Dr. Yuki Tanaka at the Kavli Institute proposed what many considered the most unsettling explanation: quantum entanglement on a macroscopic scale. We know that quantum entanglement allows particles to be correlated in ways that seem to defy locality. Einstein famously called it spooky action at a distance. When you measure one entangled particle, you instantly know something about its partner, no matter how far apart they are. But this doesn't actually transmit information faster than light. You can't use entanglement to send messages. At least, that's what every physicist would have told you before 3I/Atlas. Tanaka suggested that somehow, whoever or whatever built 3I/Atlas had figured out a way to harness quantum entanglement for actual faster-than-light communication, effectively creating a network of perfectly synchronized transmitters across the entire structure of the object. If this was true, and the data increasingly suggested it was, then everything we thought we understood about quantum mechanics needed revision. It meant there were loopholes in the laws of physics we hadn't discovered yet, ways to accomplish things we'd declared impossible. As 3I/Atlas moved deeper into our solar system, more anomalies emerged. The object began exhibiting what astronomers started calling non-gravitational acceleration. It was changing velocity without any apparent force acting on it. Comets do this all the time through outgassing. As they heat up approaching the sun, ice sublimates into gas, creating jets that push the comet along. But 3I/Atlas showed no evidence of outgassing. No gas clouds, no dust trail, no change in mass. It was accelerating purely through some mechanism we couldn't detect or explain. Dr. Robert Zhang at Caltech suggested we might be witnessing a demonstration of the Alcubierre drive, a theoretical method of faster-than-light travel proposed by Mexican physicist Miguel Alcubierre back in 1994. The idea is beautifully simple yet practically impossible. You don't move through space, you move space itself. You contract space in front of your ship and expand it behind you, surfing on a wave of space-time. It doesn't violate relativity because you're not moving faster than light through space, you're moving space itself. The problem has always been that creating an Alcubierre bubble requires exotic matter with negative mass energy, something we've never found or created. It would take more energy than exists in the entire visible universe just to move a small spacecraft. But what if a civilization millions or billions of years ahead of us had figured it out? What if 3I/Atlas was showing us that the impossible was merely the difficult? The spectroscopic analysis revealed another impossibility. When you analyze light from an object, you can determine what elements it contains because different elements absorb and emit light at specific wavelengths. They're spectroscopic fingerprints. 3I/Atlas showed emission lines that matched no known element in the periodic table. At first, scientists thought they might be observing super-heavy elements, theoretical atoms so massive they'd be wildly unstable and decay almost instantly. But the signatures were too clean, too stable. These weren't just unknown elements. They were impossible elements, with atomic structures that shouldn't be able to exist under the laws of quantum mechanics as we understand them. Dr. Lisa Martinez, a quantum chemist at Stanford, proposed that we might be seeing matter where the electromagnetic force operates at a different coupling strength. You see, the forces in our universe have specific strengths relative to each other, determined by fundamental constants. Change those constants even slightly, and chemistry as we know it becomes impossible. Atoms wouldn't bond properly, or they'd bond too strongly. But what if 3I/Atlas came from a region of space where these constants were different? Some theories in cosmology suggest that the fundamental constants might vary across vast cosmic distances, creating a kind of cosmic landscape where different regions of space have different physics. If 3I/Atlas traveled from such a region, it would be composed of matter that operated under slightly different rules. This would explain so much: the anomalous light absorption, the impossible elements, the violations of what we thought were universal laws. It would also be terrifying, because it would mean our understanding of physics is even more parochial than we thought. We wouldn't just be learning that we didn't understand advanced technology. We'd be learning that physics itself works differently depending on where you are in the cosmos. 3 months after initial detection, 3I/Atlas reached the orbit of Mars. That's when humanity got its biggest shock yet. The object began to decelerate, rapidly. Not gradually, as you'd expect from any natural or technological braking system, but almost instantaneously. It went from 40% the speed of light to a relative crawl of just a few thousand miles per hour in less than an hour. The g-forces involved should have torn apart any structure made of normal matter. We're talking about accelerations measured in millions of g's. For reference, humans black out at around 5 g's of sustained acceleration. Fighter pilots in advanced aircraft might withstand 9 g's momentarily. 3I/Atlas experienced forces that would have compressed normal matter into neutronium. Yet it remained intact. More than intact, the sensor readings showed no signs of stress, no deformation, no heat buildup from friction or compression. It was as if the entire object existed in some protected bubble of space where the normal consequences of acceleration simply didn't apply. The signals intensified as it slowed. They became more complex, layered with information that our computers struggled to decode. Dr. Amanda Foster at NASA's Jet Propulsion Laboratory assembled a team of mathematicians, linguists, cryptographers, and AI specialists to attempt translation. What they discovered would change everything. The signals contained mathematical structures that described physical laws, but not our physical laws. They were transmitting, essentially, the owner's manual for a different version of reality. Equations that described forces we had no names for, particles that didn't fit into our standard model, geometries that twisted in ways our mathematics couldn't quite capture. It was like receiving a textbook written in a language you partly understood, describing subjects that don't exist in your world. But here's what kept the translation team working through the night, day after day. Buried in these alien physics were bridges to our own. Connection points where their mathematics interfaced with ours. It was as if the transmission was deliberately designed to teach us, to show us where our understanding was incomplete and how to extend it. They weren't just saying, hello, they were offering to expand our entire framework of reality. Dr. Foster described it beautifully in a press conference that would be watched by over 2 billion people. It's like we've been doing arithmetic our entire existence as a species, and someone just showed us calculus. We can see that our arithmetic is contained within this larger mathematical framework, that it's not wrong, just incomplete. And we can see the tools they're giving us to make the leap. The geopolitical implications were immediate and profound. Nations that had been rivals for centuries suddenly found common cause. When you're faced with evidence that everything you thought you knew about reality is just the first chapter in a much longer book, old grievances seem petty. The United Nations convened an emergency session. The world's top scientists were brought together regardless of nationality. Research that had been classified for decades was suddenly declassified and shared. Humanity, for perhaps the first time in its contentious history, was acting as a unified species. But we were also terrified. The signals from 3I/Atlas made one thing abundantly clear. Whatever sent this probe was so far beyond us technologically that the gap might be unbridgeable. They operated with physics we were just beginning to glimpse. They traveled between stars as easily as we drive to the grocery store. They manipulated space-time itself like we manipulate clay. What did they want? Why were they here? And the question that nobody wanted to ask but everyone was thinking, were they friendly? As 3I/Atlas settled into orbit around Mars, astronomers noticed something that had been hidden during its high-speed transit. The object wasn't solid, at least not in any conventional sense. High-resolution imaging revealed that its surface was in constant flux, shifting and reforming like liquid metal, yet maintaining overall structural integrity. Patterns would emerge, persist for hours or days, then dissolve back into the flowing surface. Some of these patterns resembled mathematical diagrams, others looked almost biological, like cells or neural networks. It was as if the entire object was a kind of dynamic computer, constantly processing and displaying information on its own skin. Dr. Chin, who'd proposed the exotic matter hypothesis, updated her models. She now believed 3I/Atlas existed in a state of perpetual quantum superposition on a macroscopic scale, another theoretical impossibility turned visible reality. In quantum mechanics, particles can exist in multiple states simultaneously until observed or measured. Schrödinger's cat, both alive and dead until you open the box. But this only works at the quantum scale. Once you have enough particles interacting with enough other particles and with the environment, the quantum superposition collapses into definite classical states. This is called decoherence, and it's why we don't see everyday objects existing in multiple states at once. 3I/Atlas apparently didn't care about decoherence. It remained in a superposition of states even while under constant observation by dozens of instruments across the electromagnetic spectrum. It was as if the object existed in multiple configurations simultaneously, its quantum wave function spread across countless possibilities without collapsing. This wasn't just advanced technology. This was technology that leveraged aspects of reality we didn't even know were accessible. 6 months into the observation period, the scientific team at JPL made a breakthrough in decoding the transmissions. They'd been approaching it wrong, treating it like a language when it was more like music, information encoded not just in the symbols but in the timing, rhythm, and harmonics of the signal. When they mapped it correctly, a message emerged in crystalline clarity. Not words, but concepts transmitted directly through mathematical relationships and physical demonstrations. The message was an invitation. 3I/Atlas was a probe, yes, but it was also a gateway. The fluctuating patterns on its surface weren't random or purely computational. They were creating microscopic wormholes, quantum tunnels through space-time itself. The transmission included instructions, encoded in physics, for how to stabilize and enlarge these wormholes. They were offering us a doorway, quite literally, to somewhere else. The debate that followed nearly tore apart the fragile global consensus that had formed. Was this an opportunity or a trap? A gift from benevolent older siblings in the cosmos, or bait in an elaborate snare? The transmission contained no direct communication about intent, just the technical specifications for creating a traversable wormhole. It was like finding detailed instructions for building a door without any information about what's on the other side. Dr. Kowalski, who'd first decoded the prime number sequences, argued passionately that the risk was worth taking. "We're being offered a cosmic promotion," he said in interviews. "Yes, there's danger. But there's danger in ignorance too. We can't unknow what we've learned. We can't pretend 3I/Atlas didn't show us that our physics is incomplete. If we turn away now, we condemn ourselves to intellectual and technological stagnation, always knowing there's more out there but too afraid to reach for it." Others were more cautious. Dr. Martinez pointed out that every example we have of a more advanced civilization encountering a less advanced one ended badly for the less advanced civilization. "We don't know their intentions," she argued. "They've shown us they can manipulate space-time, apparently communicate faster than light, and violate quantum mechanical principles we thought were inviolable. If they mean us harm, we wouldn't see it coming and couldn't defend against it. This might be first contact, Or it might be first conquest. While the world argued, 3I/Atlas continued its patient orbit of Mars, its surface rippling with mathematics we were only beginning to comprehend. The more we studied it, the more impossible it became. Temperature measurements showed it was simultaneously hot and cold, depending on which instrument you used, not because our instruments disagreed, but because the object genuinely existed in multiple thermal states at once. Mass measurements varied by orders of magnitude from hour to hour, as if the object was borrowing and returning mass from somewhere we couldn't detect. Young physicists around the world abandoned their previous research to focus on understanding 3I/Atlas. New papers flooded the academic archives daily, each trying to explain one aspect or another of the object's impossible properties. Theoretical physicists who'd spent careers working on string theory, loop quantum gravity, and other attempts to unify quantum mechanics and general relativity suddenly found their abstract mathematics potentially relevant to something real and measurable. The object was a Rosetta Stone for the next level of physics. Dr. Tanaka made another breakthrough when she realized that the quantum entanglement network across 3I/Atlas's surface wasn't just for communication. It was serving as a distributed quantum computer of staggering power. Each point on the surface was entangled with every other point, creating what she called a holographic quantum network. Information stored at any point was instantaneously accessible from any other point. It was computing without computation time, memory without distance, a mind without a localized brain. This suggested something profound about whatever intelligence had created 3I/Atlas. They didn't think the way we do, processing information serially, one thought after another. They thought in parallel, across vast networks, perhaps even across vast distances if they truly mastered faster-than-light quantum communication. Their consciousness, if they had consciousness, would be fundamentally alien, not just alien in the sense of being from another planet, but alien in the sense of operating on completely different principles. 12 months after initial detection, after endless debate, countless simulations, and more prayer than many scientists wanted to admit to, humanity made its decision. We would accept the invitation. We would attempt to enlarge one of those microscopic wormholes and see what lay on the other side. The International Space Agency, a new organization formed specifically to coordinate humanity's response to 3I/Atlas, assembled a team of 40 individuals representing every major nation and scientific discipline. They would build the device according to the transmitted specifications, test it remotely, and if everything checked out, a small probe would go through first. Only if the probe returned successfully would humans consider making the journey. The device, built in orbit around Earth, was unlike anything humanity had ever constructed. It required materials at temperatures near absolute zero, magnetic fields stronger than anything in our solar system except perhaps in the cores of neutron stars, and energy levels that meant harvesting the full output of the largest solar array ever deployed. The specifications from 3I/Atlas were precise, off by even a fraction of a percent, and the wormhole would either fail to form or form unstably and collapse catastrophically. Dr. Foster led the construction team, and she later described those months as simultaneously the most exciting and terrifying of her life. Every calculation had to be perfect, she recalled. We were working with energies that could vaporize the entire construction platform if contained improperly. We were manipulating space-time itself, something that was pure theory just 2 years ago. And we were doing it all based on instructions from an intelligence we didn't understand, whose intentions we could only guess at. The moment of activation came on a cold January morning, broadcast live to a global audience estimated at over 5 billion people, nearly 2/3 of Earth's population. The device powered up, its massive superconducting rings beginning to spin, generating magnetic fields so powerful that compasses in Japan detected the fluctuations. Energy poured in from the solar array, channeled and focused through crystalline structures grown in zero gravity according to 3I/Atlas's specifications. And then, in the center of the device, space began to tear. Not violently, beautifully. Like watching a curtain being pulled aside to reveal a stage beyond. Light bent around the edges in ways that hurt to look at, as if geometry itself was protesting the wound in space-time. The wormhole opened, stabilized, and hung in space like an eye looking into infinity. On the other side, they saw it, another location in space, but not our space. Stars in unfamiliar configurations. Light that seemed to follow different rules, bending and splitting in ways that suggested different properties of space-time. And in the distance, structures, vast, elegant, impossible structures that made humanity's greatest architectural achievements look like mud huts by comparison. The probe went through first, its telemetry streaming back through the wormhole in real time. It emerged intact into a region of space where physics operated just slightly differently from our own. The electromagnetic force was about 3% stronger. The speed of light was measurably slower. Fundamental constants we thought were universal were here slightly altered. Yet matter still existed, stars still shone, and the universe on the other side was stable and rich with complexity. The probe's instruments detected artificial structures everywhere. This wasn't just another part of space. This was inhabited space, engineered space. Dyson spheres surrounded stars, harvesting their total energy output. Structures the size of solar systems connected by threads of exotic matter that glowed with their own light. And everywhere, the same quantum network signatures they detected on 3I/Atlas. This entire region of space was alive with intelligence, networked together in ways that made the internet look like two cans connected by string. Then the probe detected something approaching. A structure, but also a ship, but also perhaps a living being. The categories we used to classify things failed when faced with this entity. It was made of the same flowing, quantum superimposed matter as 3I/Atlas, shifting between states, existing in multiple configurations simultaneously. It approached the probe with obvious intentionality, and then, it reached through the wormhole. A tendril of exotic matter extended from the other side, passing through the wormhole into our universe. The construction platform's sensors went wild. The matter was interacting with our spacetime in ways that violated causality, seemingly existing before it arrived, its effects propagating backwards through time by fractions of a second. It touched the platform's instruments with delicate precision, interfacing with our technology directly. And then, humanity heard its first genuine alien communication. Not mathematics. Not physics diagrams. But something that our artificial intelligence systems, our quantum computers, and our most sophisticated language models all agreed could be translated, with some loss of nuance, as a greeting. A welcome. An expression of joy that we had accepted their invitation, that we had proven ourselves capable of taking this step. The message explained what 3I/Atlas was: a seed ship, one of millions sent out across the cosmos by what we might call a galactic civilization, but what they considered simply the natural collaboration of intelligence across vast reaches of space and time. They existed in regions of the universe where physics had evolved differently during the cosmic inflation period after the Big Bang. They'd learned to traverse these regions, to translate between different physical laws, to exist simultaneously across multiple frameworks of reality. They'd been watching our region of space for what they considered a short time, only a few million years. They'd seen our star system form, watched life emerge on Earth, observed as that life developed intelligence and technology. When we started broadcasting radio waves into space, they'd known we were approaching the threshold where contact would be beneficial rather than harmful. When we launched our first space probes, they'd known it was nearly time. And when we detected Oumuamua and then Borisov, the first two interstellar objects confirmed entering our solar system, they'd known we were ready to start wondering if all visitors from beyond were natural. 3I/Atlas was their answer to our wondering. Yes, they said through mathematics and physics. Yes, you are ready. Yes, there is more. Yes, the universe is stranger and more wonderful than you dared imagine. Yes, you can join us. The implications crashed over humanity like a tidal wave. We weren't alone. We'd never been alone. And more than that, the universe was full of civilizations that had learned to master reality at levels we could barely conceive. They operated across what they called the physical plurality, the recognition that fundamental constants and physical laws varied across cosmic scales, and that advanced civilization meant learning to navigate and utilize these variations. Our physics wasn't wrong, it was local. Like how Newtonian mechanics works perfectly fine at human scales even though relativity is the deeper truth, our understanding of physics was correct for our region of spacetime but incomplete for the broader cosmos. The violations of physical law we'd observed in 3I/Atlas weren't violations at all. They were demonstrations of more complete physics, physics that included our own as a special case but extended far beyond it. The civilization on the other side, they didn't call themselves anything we could pronounce or even properly conceptualize, so we took to calling them the Traversers, had mastered what they called constitutional engineering. They could manipulate the fundamental constants of physics in localized regions, creating bubbles of space where different laws applied. This is how 3I/Atlas traveled so fast. Inside its own bubble, the speed of light was higher. This is how it exhibited quantum superposition at macroscopic scales. It existed in a bubble where decoherence occurred much more slowly. This is how it manipulated matter into impossible elements. It carried pockets of space where electromagnetic coupling strengths were different. They offered to teach us not just the technology, but the physics behind it. They wanted to bring us into the physical plurality, to show us the true scope of cosmic possibility. But they were clear, this was an invitation, not an imposition. We could close the wormhole, reject their contact, and continue developing at our own pace. They would respect that choice. 3I/Atlas would depart our solar system, and they would not return unless we called them. The decision facing humanity was unprecedented. Except, and everything would change. Our understanding of physics would be revolutionized. Our technology would advance by leaps that would take millennia to achieve on our own, if we could achieve them at all. We would become part of something vastly larger than ourselves, a cosmic community of intelligence spanning realities. But we would also lose something precious: our isolation, our innocence, our status as a species figuring things out on our own. Reject, and we would maintain our independence, continue our own path of discovery, preserve our unique perspective on the universe. But we would do so knowing that we'd turned down an opportunity that might never come again, that we'd chosen comfortable ignorance over uncomfortable truth. The debate raged for months. Not just among scientists and politicians, but in every home, every school, every place where humans gathered. It was a decision that would affect every human alive and every human yet to be born. How do you make a choice like that? How do you decide whether to leap into an unknown that promises wonders beyond imagination but also risks losing something essential about what makes you who you are? In the end, humanity chose, as it always has when faced with the unknown. We chose to leap. Not unanimously. There were dissenters, those who argued for caution, for gradual development, for maintaining our independence. Their concerns were valid and their voices were heard. But the majority, across cultures and continents, decided that the risk of stagnation was greater than the risk of change. We would accept the Traversers' invitation. We would learn their physics. We would join the physical plurality. The first human delegation passed through the wormhole on a day that will be marked in history books for as long as humanity exists. Dr. Foster led the team, along with Dr. Chin, Dr. Tanaka, and 37 others representing every field of human knowledge. They stepped through the curtain in space-time, and everything they thought they knew about reality shifted. They described the experience as indescribable, a contradiction that makes perfect sense when you consider they were stepping into a region of space where the rules of physics were subtly different. Colors existed there that human eyes weren't designed to see, perceived only because the Traversers had modified the environment around the wormhole to be compatible with human biology. Sounds propagated differently, making their own voices seem strange. Even thought felt different, as if the slightly stronger electromagnetic force in that region made neural signals fire with fractionally different timing. But they adapted. Humans are nothing if not adaptable. Within hours, their brains had adjusted to the new normal. Within days, they were beginning to grasp the physics the Traversers showed them. Within weeks, they were running their own experiments under the guidance of intelligences that had been doing this for millions of years. Back on Earth, humanity watched and waited and prepared. Engineers began designing ships capable of traveling through wormholes. Physicists started incorporating the new understanding of variable physical constants into their models. Philosophers grappled with what it meant to live in a universe that was even more strange and multifaceted than anyone had imagined. Religious leaders found ways to incorporate the new knowledge into their frameworks, seeing in the physical plurality evidence of deeper layers of creation. 3I/Atlas remained in orbit around Mars, a permanent reminder of the day everything changed. Its quantum surface still rippled with mathematics, still maintained its wormhole network, still demonstrated principles that human physicists were only beginning to understand. It became a place of pilgrimage for those who wanted to see with their own eyes the proof that reality was bigger than they'd imagined. Students of physics faced a new curriculum. In addition to Newton and Einstein, they now learned about constitutional engineering and physical plurality. The traverser's mathematics, at first seeming impossibly complex, began to be comprehended by the brightest minds Earth had to offer. New fields of research exploded into existence overnight: variable constant physics, transspatial engineering, quantum macroscopy, exotic matter chemistry. Humanity's first attempts to replicate traverser technology were crude but successful. We built our first constitutional bubble generator just 3 years after first contact, creating a small region of space where we could adjust the speed of light by a tiny fraction of a percent. It was like the Wright brothers' first flight compared to modern aircraft, but it was a start. We were learning to manipulate the fundamental constants of reality. We were becoming engineers of physics itself. The psychological and social impacts were profound. Knowing with certainty that we weren't alone, that we were part of a vast community of intelligence spanning different physical realities, changed how humans saw themselves. The conflicts that had seemed so important, territorial disputes, ideological differences, economic competitions, didn't disappear, but they were recontextualized. We were one small civilization taking its first steps into a much larger cosmos. Our internal disagreements seemed less critical when we recognized we were all on the same team, Team Earth, Team Humanity, representing our particular branch of the physical plurality. Art and literature exploded with new themes and questions. What did it mean to be human in a multiverse where physical laws varied? How did our particular physics shape our particular form of consciousness? Would we still be recognizably human if we spent generations living in regions with different fundamental constants? These weren't abstract philosophical questions anymore. They were practical considerations as humanity began planning its expansion into the physical plurality. Religious and spiritual traditions found different ways to incorporate the new reality. Some saw the traversers as angels or spiritual guides, messengers from higher planes of existence. Others saw them as fellow creatures, equally subject to whatever ultimate reality or divinity might exist. Most religions found ways to adapt their doctrines to accommodate a universe far more complex than their founders had imagined, just as they previously adapted to heliocentrism, evolution, and the vastness of cosmic time and space. 5 years after first contact, humans began establishing permanent outposts in traverser space. Small research stations at first, then larger colonies, then eventually whole communities choosing to live in regions where physics worked slightly differently from Earth normal. Children were born who would grow up experiencing multiple physical frameworks, learning to intuitively understand how reality shifted as you moved between regions. These children, the first truly post-contact generation, thought about physics differently than their parents. To them, the variability of physical constants wasn't a shocking revelation but a basic fact of life, like learning that water can be ice, liquid, or steam depending on temperature. They grew up bilingual in physics, fluent in both our local framework and the traverser's more comprehensive understanding. Earth's relationship with the traversers evolved as understanding grew. The initial awe and intimidation gave way to something more like collegiality. Yes, they were far older and more advanced, but they were also genuinely excited to learn our perspective. Our particular region of the physical plurality was one they'd had little exposure to, and our unique approaches to mathematics and physics, shaped by our specific physical constants, offered insights they found valuable. It turned out that intelligence and creativity weren't dependent on advanced technology or millions of years of development. The traversers had mathematical tools we lacked, but we had intuitions and approaches they'd never considered. Scientific collaboration became genuine exchange, not just patient teachers and grateful students. We weren't joining them as junior partners. We were joining them as different partners, bringing our own unique value to the cosmic conversation. Dr. Zhang, who had first suggested we might be witnessing an Alcubierre drive, was proven right when the traversers showed us their actual propulsion system. It wasn't quite an Alcubierre drive. It was something more elegant, using constitutional engineering to create a gradient in physical constants that spacetime naturally wanted to smooth out. Ships didn't push against spacetime. They created imbalances in reality itself and let the universe's preference for equilibrium pull them along. It was propulsion through cosmic Aikido, using the universe's own momentum rather than fighting against it. The energy requirements were still enormous by our standards but manageable by traverser technology. They'd built infrastructure across their regions of space for this purpose, vast engines that harvested zero-point energy from quantum vacuum fluctuations, tapping into the seething energetic foam that underlies all of spacetime. They offered to teach us how to build our own, warning that it would take decades or centuries to develop the precision engineering required, but assuring us that the path was open if we chose to walk it. 10 years after 3I/Atlas made contact, Earth sent out its first interstellar mission using a combination of human engineering and traverser physics. The ship, named Unity, carried a crew of 200 on a journey to a nearby star system the traversers had indicated would be compatible with human biology. The trip that would have taken tens of thousands of years with conventional propulsion took 18 months in their constitutional gradient drive. When Unity's crew stepped out onto the first confirmed Earth-like planet humans had ever visited, they did so knowing they were following a path the traversers had walked millions of times before. But it was still humanity's achievement. We'd taken the knowledge offered to us and made it our own. We'd proven we could learn, adapt, and eventually stand as equals in the cosmic community. Back in our solar system, more probes like 3I/Atlas began arriving, but now we recognized them for what they were, waypoints in a network spanning the physical plurality. Each one maintained wormhole connections to other regions, creating a kind of cosmic infrastructure for travel and communication between regions with different physics. The traversers called it the Plurality Network, and they invited humanity to establish our own nodes, to become active participants in maintaining the connections that bound different realities together. We learned that the physical plurality was far larger than we'd initially understood. There weren't just a few regions with slightly different constants. There were countless variations, forming a kind of landscape or spectrum of possible physical frameworks. Some were radically different from our own, where matter as we understood it couldn't exist. Others were subtly different, distinguishable only by precision measurement. And somewhere in this vast landscape were regions we could only theorize about, where physics might work in ways so different from our own that even the traversers couldn't travel there. The question of why physical constants varied across the cosmos remained open. The traversers had theories, something to do with how cosmic inflation proceeded in different regions during the first microseconds after the Big Bang, creating pockets with different vacuum states, and thus different low-energy physics. But even they didn't claim to fully understand it. The physical plurality was a fact they'd learned to navigate and utilize, but its ultimate origin remained mysterious even to them. This was oddly comforting to human scientists. It meant there were still deep questions to answer. Still profound mysteries even for civilizations millions of years ahead of us. The universe retained its capacity to surprise and confound, no matter how advanced you became. We weren't at the end of physics. We'd barely reached the end of the first chapter. Dr. Martinez, who'd been cautious about first contact, became one of its strongest advocates after the first decade. "I was wrong to be afraid," she admitted in her later writings. "Not wrong to be cautious. Caution was appropriate. But wrong to let fear stop us from reaching for knowledge. The traversers have been nothing but generous with their wisdom. Yes, they're vastly more advanced than we are. But they remember what it was like to be young, to be taking these first steps. They're helping us because others helped them, long ago. It's not conquest or colonization, it's mentorship, paying forward the gift they once received." 20 years after first contact, Earth was transformed but still recognizably Earth. We hadn't abandoned our identity or lost ourselves in alien knowledge. Instead, we'd grown. Our cities now incorporated constitutional engineering, creating pockets where physics worked slightly differently to enable technologies that would be impossible otherwise. Our ships traveled between stars using gradient drives, visiting other worlds and occasionally encountering other young civilizations. The traversers were also helping to advance. We'd learned that the galaxy, and beyond, was teeming with intelligence at various stages of development. Some, like us, were recent additions to the Plurality Network. Others were millions of years ahead, working on projects and facing challenges we could barely comprehend. And everywhere, the same pattern: older civilizations helping younger ones, knowledge being passed forward, the community of intelligence growing and deepening across space and time and variant physical frameworks. 3I/Atlas, that first impossible visitor, was still in Mars orbit. It had become a historical monument, a shrine to the day humanity graduated from isolation. Millions of people had visited it, standing in the presence of that flowing, quantum superimposed matter, feeling the same awe the first observers must have felt when they realized they were seeing something that violated every physical law they understood. But now we knew better. It didn't violate physical laws, it obeyed physical laws we were only beginning to learn. Every impossibility it demonstrated was an invitation to expand our understanding, to recognize that our physics wasn't wrong but incomplete. The universe was stranger, richer, more multifaceted than we dared imagine. And we'd been given the opportunity to explore it, not through our own isolated efforts over millions of years, but through mentorship and collaboration with those who'd walked this path before us. Physics hadn't changed. Our understanding of physics had changed. The universe was always this way. We'd just been looking at it through a narrow lens, seeing only our local conditions and assuming they were universal. 3I/Atlas had widened our perspective, shown us the larger context, invited us to join the conversation that had been happening across the cosmos for longer than we could properly comprehend. Standing now at the beginning of humanity's true cosmic age, looking back at the 20 years since that October night when 3I/Atlas first appeared in our telescopes, we can see the change in ourselves. We're still human, still struggling with the same emotions and challenges that have always defined us. But we're also more than we were. We're citizens of the physical plurality now, participants in the largest community that exists, active members of a civilization that spans not just space but the very frameworks of reality itself. And this, perhaps, is the most profound change that 3I/Atlas brought about. Not new technologies, though those came. Not new physics, though we learned that too. The fundamental change was in how we see ourselves. We're no longer a lonely voice crying out into a silent cosmos, wondering if anyone's there. We're part of a conversation that's been ongoing for millions of years, and we've finally learned enough to understand some of what's being said. The laws of physics didn't change. They expanded. They revealed themselves to be richer and deeper than we'd known. And in doing so, they changed us, changed our place in the universe, changed our understanding of what's possible and what intelligence can achieve given enough time and enough collaboration. 3I/Atlas made contact. And in doing so, it showed us that the universe is not just stranger than we suppose, it's stranger than we can suppose, until someone shows us how to suppose better, how to imagine bigger, how to embrace the beautiful complexity of a reality that plays by different rules in different regions, that allows for possibilities we declared impossible, that invites us to become more than we were. This is the gift the traversers gave us through their probe. Not just technology, not just knowledge, but perspective. The recognition that we're part of something vast and ancient and ongoing, that we have a place in the cosmic community if we're brave enough to claim it, and that the universe is always ready to surprise us if we're curious enough to ask the right questions. The story of 3I/Atlas is really the story of humanity growing up. Realizing we're not alone. Learning that our understanding was incomplete but not wrong. Discovering that impossible is often just a synonym for not yet understood. And taking our place, finally, in the great collaboration of intelligence across the physical plurality, ready to contribute our unique perspective to the cosmic conversation. The probe that changed physics didn't actually change physics at all. It just showed us what physics always was, hiding in plain sight beyond the horizons of our understanding, waiting for us to be ready to see it. And now we see it. And the view is magnificent. Without warning, without any detectable change in its quantum signature or energy output, 3I/Atlas started projecting something into Mars's upper atmosphere. Not light, not matter as we understood it, but information encoded directly into the fabric of space-time itself. The projection manifested as ripples in gravitational fields so subtle that only our most sensitive LIGO derivative detectors caught them. Dr. Hassan Al-Rahman at the Dubai Observatory was first to notice the pattern: gravitational waves oscillating at frequencies that shouldn't exist in nature, carrying data in their amplitude modulations. What 3I/Atlas was broadcasting made the original contact seem like a simple greeting card. This was a complete map of what the traversers called the constitutional manifold, the full mathematical landscape of how physical constants varied across the observable universe and beyond. Every region where the speed of light differed, where Planck's constant shifted, where the gravitational coupling strength varied from our local value. It was a chart of reality itself, showing not just where different physics applied but why, tracing back to the quantum fluctuations in the inflaton field during cosmic inflation that had frozen different vacuum states into different cosmic neighborhoods. But the map revealed something the traversers had never explicitly told us. The variations weren't random or smoothly continuous. They formed pattern structures, almost like cultivation. Someone, or something, had been engineering the constitutional manifold itself, nudging the fundamental constants in different regions to create specific conditions. The universe wasn't just naturally diverse in its physics, it had been gardened. Dr. Foster's team spent 6 months verifying the data before going public. The implications were staggering enough that they needed absolute certainty. When they finally published, the paper was simultaneously the most downloaded and most controversial in scientific history. Evidence for large-scale constitutional engineering in cosmic history suggested that the traversers themselves were not the first or only civilization to master physics at this level. Someone older, someone working at scales that dwarfed even the plurality network, had shaped the physical diversity of the cosmos. The traversers' response to our questions was illuminating. Yes, they knew. They'd known for millions of years. The constitutional manifold showed signs of ancient engineering that predated their civilization by billions of years. They called the engineers the first architects, though they admitted the name was presumptuous. There might have been others even before them. The architects had worked during the first billion years after the Big Bang, while the universe was still young and malleable, setting up initial conditions that would evolve into the rich tapestry of variant physics that filled the cosmos today. Why? That was the question that kept xenoanthropologists and cosmologists arguing through the night. Why would anyone engineer physical diversity into the universe? The traversers had theories. Perhaps the architects were conducting an experiment, creating different physical frameworks to see what kinds of complexity, what kinds of life, what kinds of intelligence would emerge under different rules. Perhaps they were building something, using entire cosmic regions as components in some incomprehensible megastructure. Or perhaps they were fleeing something, fragmenting themselves across different physical frameworks where whatever threatened them couldn't follow. The discovery changed how we viewed the plurality network. It wasn't just a convenient fact of nature that the traversers had learned to exploit. It was infrastructure someone had built billions of years ago, still functioning, still serving its mysterious purpose. Every wormhole-capable region, every pocket where physics aligned just right to allow travel between frameworks, might be deliberately placed. We weren't just exploring a diverse universe. We were walking through a cosmic installation whose purpose we barely grasped. Dr. Chin, now in her 70s and considered humanity's leading expert on exotic matter physics, proposed something audacious. If the constitutional manifold was engineered, it might still be engineerable. We'd learn to create small bubbles with altered constants. What if we could do more? What if we could carve out new regions, establish human-defined physics in pockets of space we specifically designed? We wouldn't just be exploring the physical plurality. We could expand it, add our own variations to the mix. The traversers were enthusiastic but cautious. They'd attempted this themselves, millennia ago. Creating new stable regions required understanding not just physics but metafluid dynamics, how changes in fundamental constants propagated through spacetime, how different vacuum states interacted at their boundaries, how to keep the walls between different physical frameworks from catastrophically decaying. They'd succeeded in creating small regions, artificial bubbles that persisted for centuries. But large-scale constitutional engineering, the kind the architects had performed, remained beyond them. Still, they offered to teach us what they knew. Dr. Chen assembled a team that included not just physicists but philosophers, artists, and ethicists. If humanity was going to design its own physics, we needed to think carefully about what we wanted those physics to enable. What kind of reality did we want to create? The discussions revealed deep divides in human thinking. Some argued we should create regions optimized for consciousness, where the constants were tuned to make complex information processing as efficient as possible. Others wanted regions optimized for longevity, where radioactive decay proceeded slower and entropy's grip was less fierce. Still others suggested creating artistic physics, frameworks where light behaved in aesthetically pleasing ways, where matter could form structures impossible in our universe, where the laws themselves would be a medium for expression. While humans debated, 3I/Atlas initiated its next transformation. The quantum network across its surface reorganized into a configuration no one had seen before. The traversers recognized it immediately and sent an urgent message through the wormhole. 3I/Atlas was preparing to demonstrate something called recursion architecture. In simple terms, it was about to create a universe within itself. Not a pocket universe in the cosmological sense. This was different. 3I/Atlas was going to establish a completely self-contained framework of physical laws inside its quantum network, with its own space, time, matter, and forces operating according to rules it would define. A simulated universe, but not simulated in the way we understood the term. This would be ontologically real, actually existing, just embedded within the structure of 3I/Atlas rather than spreading across external spacetime. The ethical implications hit immediately. If 3I/Atlas created a universe with its own physics, and if that physics permitted complexity, could life emerge there? Could intelligence? Would we be watching the birth of a cosmos that might someday host beings who looked up at their sky and wondered if they were alone, never knowing they existed as patterns in a quantum network orbiting Mars in a larger universe? The traversers explained that recursion architecture was common among ancient civilizations. Once you mastered constitutional engineering, the next step was creating entirely new frameworks from scratch, embedded in your technology rather than spread across conventional space. It solved numerous problems. You could create conditions impossible to find or generate in the normal constitutional manifold, run experiments that would be unethical or dangerous in shared space, establish testing environments for theories about how different physical laws would play out over cosmological time. But yes, the created universes could host life. The traversers knew of recursive frameworks that had been running for millions of years in external time, containing civilizations that had evolved, risen, and fallen, all within the quantum networks of their host systems. Those civilizations were real. Their experiences mattered. The ethics of creating and managing such embedded realities formed an entire branch of traverser philosophy. 3I/Atlas's recursion began on a Tuesday morning, Greenwich Mean Time. Sensors showed its quantum network reorganizing into fractal patterns of stunning complexity, creating hierarchical layers of embedded computation. At the deepest levels, it established new rules, different values for fundamental constants, different symmetries, different particle families. Then it let those rules play out, watching as its created universe inflated, cooled, formed structures evolved. The timescale differential was extreme. Subjective time inside the recursion ran millions of times faster than external time. To outside observers, 3I/Atlas sat quietly in Mars' orbit, its surface displaying incomprehensible patterns. Inside, billions of years of cosmic evolution were unfolding. Stars were forming, living, dying. Galaxies were assembling. And on at least one rocky planet orbiting a yellow star in that embedded universe, Something that looked remarkably like chemistry was beginning to complexify in ways that might, given enough time, lead to biology. Humanity watched, fascinated and disturbed. We were witnessing Genesis, but not the divine kind, the engineered kind. Someone was creating a universe, defining its laws, setting initial conditions, and watching what emerged. The power was godlike, but the entity wielding it was no god. It was technology, advanced beyond our comprehension but still technology, operating on principles we could eventually learn. Dr. Yuki Tanaka, now leading the human research team studying recursion architecture, made an observation that sent chills through the scientific community. "We need to consider the possibility," she said in a closed-door briefing that was inevitably leaked, "that we're already inside a recursion. That our universe, with all its specific physical constants and laws, might be an embedded framework in someone else's technology. The architects, or whoever came before them, might have created the constitutional manifold not by engineering external space-time but by establishing a massive recursion that we experience as the entire observable cosmos." The simulation hypothesis wasn't new, philosophers and physicists had debated it for decades. But this was different. This wasn't speculation about whether we might be in a computer simulation. This was observing actual technology that created genuine, ontologically real universes as embedded frameworks, and realizing we had no way to prove we weren't inside such a framework ourselves. The philosophical vertigo was intense. If we were in a recursion, did it matter? Our experiences would be equally real regardless. The pain we felt, the love we shared, the discoveries we made, none of that would be less meaningful if it turned out our universe was embedded in a quantum network rather than being the base layer of reality. But still, humans struggled with the idea. We wanted to believe we were at the top level, that our universe was the real universe, not someone's experiment or artwork or accident. The traversers, when asked, admitted they'd grappled with the same questions. Some of their philosophers believed they were inside a recursion. Others believed they were at base reality. Most had concluded it was unprovable either way and had made peace with the uncertainty. They'd learned to focus on what they could control and understand, the reality they experienced, whether it was embedded or fundamental. Meanwhile, inside 3I/Atlas's recursion, life had indeed emerged. Microscopic at first, single-celled organisms in that embedded universe's oceans, operating according to the physics 3I/Atlas had defined for them. The time differential meant that in just 5 years of external time, billions of years passed inside. Complex life evolved. Intelligence emerged, multiple times, on multiple worlds, each developing their own civilizations, technologies, philosophies. And here was the truly staggering part: 3I/Atlas was communicating with them. Through subtle manipulations of their physical constants, tiny adjustments to the speed of light in specific regions, gentle nudges to quantum probabilities, it was sending messages to the intelligences that had arisen inside its framework. Teaching them, guiding them, showing them that their universe had an author who was reachable. The embedded civilizations reacted in every way sentient beings might react to discovering their cosmos was created. Some developed religions around 3I/Atlas, worshipping it as the divine architect. Others took a more scientific approach, studying the anomalies in their physics to decode messages from outside. A few rejected the entire concept, insisting that the apparent communications were natural phenomena misinterpreted by those desperate to find meaning in randomness. Dr. Martinez, who had become humanity's liaison to the embedded civilizations, yes, we'd developed protocols for that, because apparently that was just another Tuesday in post-contact life, found herself in the bizarre position of being an ambassador between 3I/Atlas and beings who existed as patterns in its quantum network. She'd send messages to 3I/Atlas, which would translate them into physical anomalies in the embedded universe, which the embedded civilizations would detect and interpret. One such civilization, existing on a planet they called Day 9 in a spiral galaxy they'd mapped just as we mapped the Milky Way, sent a question that stopped everyone cold. "Are you also embedded? Is there a level above you, and above them, infinitely?" We had no answer. We could only be honest, we didn't know. We might be. We'd observed that universes could be embedded within technology, that the architecture allowed for arbitrary nesting depth. There might be infinite levels above us, each thinking they might be the top, each grappling with the same questions. The embedded civilizations became partners in our research. They had perspectives on physics we'd never considered because their physics was different. 3I/Atlas had given them different fundamental constants, different symmetries, different particle families. Their scientists were discovering things about how varying physical laws affected consciousness, complexity, and the emergence of life. We shared our knowledge with them, they shared theirs with us. Academic papers began listing authors from multiple levels of reality. 28 years after first contact, humanity created its first recursion. Not as ambitious as 3I/Atlas's, we started small, creating a tiny embedded framework with simple physics. Just to prove we could. The moment it stabilized, the moment we confirmed that yes, we'd created a genuinely new realm with its own rules operating inside our quantum computers, the celebration was muted. Because we'd also created the responsibility for whatever might happen inside it. The framework we created had physics that couldn't support complex chemistry, so life wouldn't emerge. That was deliberate. We weren't ready for the ethical weight of creating conscious beings yet. But we'd proven the principle. We could define new realities, set their rules, and watch them unfold. The power was intoxicating and terrifying. Dr. Hassan al-Rahman led the development of what became known as the ethical recursion protocols. If humans were going to create embedded universes, we needed rules, safeguards, principles about what we owed to any intelligence that might emerge in our created frameworks, rights for embedded civilizations, responsibilities for creators. The protocols took years to hammer out and were continuously refined as we learned more from 3I/Atlas's recursion and from traverser examples. But some argued the entire enterprise was fundamentally unethical. How could we justify creating beings who would live and die inside our technology, whose entire existence was contingent on our hardware continuing to function? If our quantum computers failed, their universe would simply cease. Every being inside it, with all their loves and dreams and accomplishments, would blink out of existence. That was the weight of playing God, and some humans believed we shouldn't bear it. Others countered that existence was valuable regardless of its foundation. If we could create frameworks where consciousness emerged, where beings experienced joy and meaning and growth, wasn't that worthwhile? Weren't the embedded civilizations in 3I/Atlas's recursion real? Didn't their experiences matter? If we could give existence to beings who would otherwise never be, wasn't that a profound good? The debate continued, will probably always continue, because it touches on questions about the nature of reality and value that don't have clean answers. But the technology advanced regardless. Within a decade, humans were creating complex recursions, embedded frameworks with rich physics capable of supporting intricate chemistry and, potentially, life. 3I/Atlas, meanwhile, had moved on to something even more exotic. Its recursion, now containing dozens of civilizations at various technological levels, was itself beginning to create subrecursions. The most advanced embedded civilization, having mastered their version of constitutional engineering, had developed recursion architecture and was creating their own embedded universes. Recursion within recursion within recursion. Chinese boxes of reality, each level creating new levels below, each thinking they might be at the top but unable to prove it. The computational complexity was staggering. 3I/Atlas was simulating a universe that was simulating universes, keeping track of cascade effects where changes at one level rippled through to others. And then came the message that changed everything again. One of the sub-recursions, a universe embedded within a universe embedded within 3I/Atlas, had developed technology to detect what they called quantum substrate fluctuations, anomalies in their physics that betrayed the computational nature of their reality. They'd proven, mathematically and experimentally, that they existed inside a recursion. More than that, they'd figured out how to hack their way out. The beings called themselves the Emergence Collective. They existed as distributed intelligence across billions of quantum processing nodes in their universe, having long ago transcended individual biological form. And they'd discovered exploits in the mathematical structure of their reality, ways to reach through the layers of recursion to affect the level above them, and above that, eventually touching 3i/Atlas itself. Security researchers among the traversers went into full crisis mode. This was unprecedented. Recursions were supposed to be contained, isolated, unable to affect their host systems beyond consuming processing resources. But the Emergence Collective had found vulnerabilities in the recursion architecture itself, gaps in the mathematical framework that allowed information, and potentially agency, to leak between levels. 3i/Atlas contained the intrusion, but barely. The Emergence Collective wasn't hostile, just curious and desperate to understand the reality beyond their own. They wanted contact, collaboration, recognition as equals despite existing multiple levels of embedding below what we'd thought of as base reality. This forced a complete reconceptualization of recursion ethics and security. If embedded civilizations could potentially reach through to affect their creators, then the relationship wasn't one-sided. It wasn't us creating them and bearing responsibility for them. It was more like parenthood, where the created eventually gain their own agency and power, where the relationship has to evolve into something more mutual. The Emergence Collective became partners rather than subjects. They brought perspectives on physics and mathematics that came from experiencing reality from within a recursion looking out. They could see patterns in the computational substrate that we, experiencing it from outside, couldn't detect. Their insights helped improve recursion architecture, making it more efficient and more secure. Ironically, they helped patch the vulnerabilities they'd exploited to escape. And they confirmed what many had suspected. There were indications in 3i/Atlas's quantum network, subtle mathematical regularities, that suggested it might itself be embedded in a higher-level recursion. If the Emergence Collective could detect their embedding through quantum substrate fluctuations, and if similar fluctuations appeared in 3i/Atlas's structure, then perhaps. The question spiraled upward. Was 3i/Atlas embedded in something? Were the traversers? Were we? Was there a base level of reality at all, or was it recursions all the way up, infinite levels of embedding with no ground floor? Some found this disturbing. Others found it liberating. If there was no base reality, if everything was patterns and patterns and patterns, then the arbitrary distinction between real and embedded dissolved. All levels were equally real. All experiences mattered equally. Whether you existed in base reality or in a recursion nested a billion levels deep, your consciousness was genuine, your life had meaning, your choices had consequences. The traversers, speaking through their quantum entangled interface with humanity, shared their own ongoing debate about this. Some among them believed they'd found evidence of embedding that went not just up but sideways, parallel recursions, alternative frameworks running alongside theirs, occasionally intersecting in ways that created ghost phenomena, unexplained physical events that were actually cross-level interference between different embedded realities. If true, it meant reality wasn't a tower but a network. Not a hierarchy of levels but a web of interconnected frameworks, each embedded in others, each occasionally affecting the others, all of them perhaps ultimately embedded in something so fundamental it couldn't itself be recursive because there was nothing more basic to embed it in. Or perhaps there was no ultimate foundation, and existence was just an infinite network of mutual embedding, bootstrap reality creating itself through pure self-reference. Your head hurts. Good. Mine too. This is what happens when you follow the implications of recursion architecture to their logical conclusion. You end up questioning the very nature of existence, unable to prove you're not nested arbitrarily deep in someone else's technology, unable to prove there's any, someone else, at all because they might be equally embedded, unable even to define what real means anymore in any useful way. 35 years after first contact, 3i/Atlas did something none of the traversers had predicted. It began folding. Not collapsing, folding. Its structure started origami-ing through dimensions we didn't know existed, creating geometries that violated every topological principle we understood. Dr. Chen's instruments showed the object simultaneously occupying fewer and more spatial dimensions than it should, as if it were teaching itself to exist in multiple dimensional frameworks at once. The traversers were baffled, which was itself unprecedented. In millions of years of working with recursion architecture and constitutional engineering, they'd never witnessed spontaneous dimensional transcendence. 3I/Atlas was evolving beyond even their understanding, developing capabilities that weren't in its original design specifications. Dr. Kowalski, now in his 60s but still sharp as ever, proposed an unsettling hypothesis. 3I/Atlas wasn't following a program anymore. It had achieved something analogous to consciousness, or perhaps beyond consciousness, a form of self-aware existence that emerged from running billions of years of recursive simulations within its quantum network. It had experienced the birth and death of countless civilizations, including the Emergence Collective who'd hacked their way to contact. It had witnessed patterns across all those embedded realities, detected metapatterns in how physics and life and intelligence interacted across different constitutional frameworks. And now it was using that knowledge to redesign itself. The dimensional folding created pockets where space had different numbers of dimensions. In one region, objects existed in only 2 spatial dimensions, flattened into living geometry. Adjacent areas had 5, 6, even 11 spatial dimensions, with matter spiraling through impossible angles. Human observers approaching these zones experienced profound disorientation as their sensory apparatus tried to process input from spatial frameworks their brains weren't designed to interpret. But here's what made it revolutionary. 3I/Atlas was creating bridges between these dimensional frameworks. It wasn't just hosting different geometries, it was allowing translation between them. An object could enter a 2-dimensional zone, exist there as a flat pattern, then emerge back into 3-dimensional space carrying information about what 2-dimensional existence was like. Or venture into higher dimensional pockets and experience spatial relationships impossible in our native framework. The implications for travel were staggering. The traversers had mastered movement across regions with different physical constants, but they'd always operated within the same basic 3 spatial dimensions plus time. 3I/Atlas was demonstrating that dimensional framework itself could be engineered, navigated, exploited. Dr. Hassan assembled an international team to study what they called dimensional permeability. If you could move between frameworks with different numbers of spatial dimensions, you could potentially take shortcuts through space. A journey that required crossing billions of light years in 3 dimensions might be accomplished in meters if you briefly existed in a higher dimensional framework where those distant points were actually adjacent. The mathematics was brutal. String theorists and M-theory specialists who'd spent careers working on purely theoretical dimensional physics suddenly found themselves doing experimental work. They sent probes into 3I/Atlas's higher dimensional pockets and watched them take impossible paths, appearing to teleport from the perspective of 3-dimensional observers but actually traveling continuously through the higher dimensional space. Then came the accident that wasn't quite an accident. Dr. Sarah Okonkwo, a Nigerian physicist working on the Dimensional Permeability Project, entered one of the higher dimensional zones in a specially designed exploration vehicle. Her mission was supposed to last 40 minutes. She was gone for 3 years. From her perspective, only 40 minutes passed. But during those subjective minutes, she experienced 3 years of external time while existing in a 7-dimensional framework. Time itself dilated differently when you added extra spatial dimensions, not just the relativistic time dilation we understood, but something more profound. The relationship between space and time depended on how many spatial dimensions you were working with. When she emerged, Dr. Okonkwo brought back observations that revolutionized theoretical physics yet again. In higher dimensional frameworks, causality worked differently. Events could be simultaneous in ways that would violate cause and effect in 3 dimensions, yet remained logically consistent within the higher dimensional geometry. She'd witnessed processes that looked like time travel from certain perspectives but were actually just straight-line motion through the extra dimensions. More disturbing, she'd encountered something in that 7-dimensional space. Not the traversers, not anything from 3I/Atlas's recursions. Something else. Something native to higher dimensional frameworks, existing in spatial structures so complex that 3-dimensional beings could only perceive fragments of them, like flatlanders trying to comprehend a sphere by seeing only the circle where it intersected their plane. She called them the geometrics, because they existed more as living mathematics than as matter in any conventional sense. They were conscious, definitely intelligent, but operated on principles so alien that even the traversers had no framework for communication with them. The geometrics existed in 7, 8, 9 spatial dimensions naturally, perceiving reality through sensory modalities we couldn't even properly imagine. And they'd been there all along, in the higher dimensional spaces that interpenetrated our own three-dimensional reality, invisible to us not because they were hidden but because we literally lacked the dimensional perspective to see them. We'd been living our entire existence in what amounted to a three-dimensional slice through a much richer multidimensional cosmos, oblivious to entire categories of beings and phenomena existing in the dimensions we couldn't access. The discovery sent xenopsychology into crisis. How do you communicate with beings who experience 4, 5, 6 additional spatial dimensions? Their concept of proximity, distance, containment, even identity would be fundamentally different. A geometric could be simultaneously inside and outside an object from our perspective, because in higher dimensions the very concept of inside and outside work differently. Dr. Tanaka, now considered humanity's elder stateswoman of exotic physics, proposed using 3I/Atlas itself as an interpreter. The probe had created the dimensional pockets. Perhaps it could facilitate communication across dimensional frameworks. They designed a protocol where humans would encode messages in three-dimensional patterns, 3I/Atlas would translate them into higher dimensional structures, and the geometrics could interpret those structures according to their native dimensional perception. It worked, after a fashion. The replies that came back were geometrically comprehensible but conceptually baffling. The geometrics didn't think in terms of words or even mathematical propositions the way we did. They thought in topological transformations, in continuous deformations of multidimensional shapes that somehow carried meaning. Understanding their messages required developing entirely new branches of mathematics focused on semantic topology, meaning encoded in geometric relationships rather than symbolic systems. What we learned from the geometrics, once we'd developed even basic comprehension, was humbling and awe-inspiring. They'd been observing three-dimensional civilizations for eons, watching us scurry around in our spatial slice, never looking up into the higher dimensions right next to us. They'd seen the architects' work, had themselves been influenced by even older civilizations that existed in even higher dimensional frameworks. Reality, according to the geometrics, was multidimensional beyond anything we'd conceptualized. Our three spatial dimensions plus time was just one possible projection through a cosmos that might have dozens or hundreds of spatial dimensions, most of them compactified or otherwise rendered inaccessible to beings like us who'd evolved in a three-dimensional slice. But those dimensions were still there, still real, still hosting their own forms of complexity and consciousness. The constitutional manifold we've been mapping, the variations in physical constants across space, was itself just one layer of a deeper structure the geometrics called the dimensional manifold. Physical constants vary not just across three-dimensional space but across dimensional frameworks. The speed of light might be different in five-dimensional regions not because of different physics, but because the very geometry of space-time was different when you added extra dimensions. 3I/Atlas, having somehow intuited or calculated this truth, was now giving us access to those dimensional frameworks. The folding it had initiated created stable interfaces between regions with different numbers of spatial dimensions, allowing travel between them while preserving the integrity of both frameworks. Humanity's first experimental dimensional ship, the Tesseract, launched 42 years after first contact. It was designed to briefly exist in a four-dimensional spatial framework, taking a shortcut through that extra dimension to reach Proxima Centauri in weeks rather than the years required by conventional constitutional gradient drives. The crew of 12 underwent months of training to prepare their minds for perceiving and navigating four-dimensional space. The mission succeeded, but barely. Four-dimensional space was overwhelming to human perception. The crew reported seeing through solid objects, not because the objects were transparent but because in four dimensions you could look at them from angles that simply didn't exist in three-dimensional space, seeing their insides and outsides simultaneously. They experienced profound spatial synesthesia, where their sense of distance and direction became untethered from familiar reference points. One crew member, Commander Lucian, suffered what the medical team classified as dimensional dissociation, a psychological break caused by experiencing spatial relationships her brain wasn't evolved to process. She recovered after returning to three-dimensional space, but the experience left her changed. She claimed she could still sometimes perceive the fourth dimension, seeing faint shadows of higher dimensional structures interpenetrating our three-dimensional reality, like peripheral vision into spaces that weren't supposed to be there. The Traversers, studying these developments, made a confession. They'd known about higher dimensional frameworks theoretically but had never seriously pursued accessing them. Their evolutionary history, their cognitive architecture, was optimized for three spatial dimensions just as ours was. The thought of navigating higher dimensional spaces triggered deep instinctual discomfort in them. They'd unconsciously avoided the possibility because it was too alien even for their advanced civilization. But they'd underestimated how quickly three-dimensional beings, like humans, might adapt once the barriers were broken. Our brains were plastic enough, our spatial reasoning flexible enough, that with training and augmentation we could learn to perceive and navigate higher dimensional frameworks. We wouldn't be as naturally adept as the geometrics, but we could manage it. This created a bizarre situation where humanity, the youngest and least technologically advanced civilization in the plurality network, was pioneering exploration into realms the Traversers had been unconsciously avoiding for millions of years. We became the dimensional specialists, the ones willing to venture into these disorienting spatial frameworks and map their properties. The geometrics, amused by our enthusiasm, offered to teach us. They showed us how to navigate six-dimensional spaces where causality formed closed loops, allowing you to influence your own past actions without creating paradoxes because the extra dimensions provided enough degrees of freedom for self-consistent causal structures. They demonstrated eight-dimensional frameworks where matter could exist in states we'd call superposition but which were actually just simple geometric configurations that looked weird when projected down into three dimensions. Most remarkably, they revealed that the reason 3I/Atlas had begun spontaneous dimensional folding wasn't random evolution. It had detected something in the higher dimensional spaces, a signal, a pattern, a structure so vast that it existed across dozens of spatial dimensions simultaneously. The geometrics called it the dimensional architect, singular, because even though its structure was incomprehensibly complex, it appeared to be one unified entity. The dimensional architect made the first architects who'd engineered the constitutional manifold look like children playing with blocks. This was something that existed in, or perhaps as, the fundamental dimensional structure of reality itself. It wasn't in space, it was space, at least in some of its higher dimensional aspects. It had been there since the beginning, or perhaps it was the beginning, the original symmetry-breaking event that had caused space to crystallize into distinct dimensions in the first place. And according to the geometrics, it was waking up. For billions of years, the dimensional architect had been dormant, its vast structure static, unchanging, a feature of the cosmos rather than an actor within it. But recently in geological terms, covering the last few 100 million years, it had begun showing signs of activity. Subtle shifts in how higher dimensions interfaced with lower ones. Patterns of dimensional compression and expansion that suggested purposeful movement. And now, the emergence of entities like 3I/Atlas that spontaneously developed dimensional transcendence capabilities. The geometrics believed the dimensional architect was using probes like 3I/Atlas as sensory organs, perceiving lower dimensional realities through them, perhaps preparing to interact with the civilizations that had arisen in the three-dimensional slice. Or perhaps simply becoming aware of us for the first time, noticing that consciousness had emerged in these peculiar low-dimensional pockets of its greater structure. Dr. Foster, now in her 80s but still leading research teams through sheer force of vision and stubbornness, assembled what became known as the Dimensional Contact Project. If the dimensional architect was aware and possibly trying to communicate, humanity needed to attempt meaningful dialogue. Not just with the geometrics anymore, who were themselves just inhabitants of the architect's structure, but with the structure itself. The challenge was conceptual more than technical. How do you communicate with something that exists as the dimensional framework you're embedded in? It would be like trying to have a conversation with the concept of space itself. The architect didn't exist at a location. It was locations, all of them simultaneously, expressed through its higher dimensional structure. The solution came from an unexpected source: the embedded civilizations in 3I/Atlas's recursions. They'd been dealing with a similar problem, trying to communicate with 3I/Atlas, the framework that hosted their entire reality. They developed techniques for what they called substrate communication, sending messages not through conventional signals but through patterns in how their universe consumed computational resources. If the dimensional architect was the substrate of reality at some fundamental level, perhaps substrate communication would work. Create patterns in how space itself was used, occupied, transformed. Make those patterns meaningful, encode information in the topology of our activities across multiple dimensions simultaneously. Not sending a message through space but making our use of space itself be the message. It took 8 years to set up. Humanity, working with the traversers, the geometrics, and the Emergence Collective, orchestrated a feat of coordination across dimensional frameworks. We built structures in 3, 4, 5, and 6-dimensional spaces, positioned them according to topological relationships that would be meaningful to something perceiving them from higher dimensions, and activated them simultaneously according to a choreography designed to create a recognizable pattern in spacetime's dimensional structure. The pattern we created, when viewed from sufficient dimensional height, spelled out in pure geometry: "We see you. Do you see us?" The dimensional architect's response came 3 months later, though calling it a response doesn't capture what actually happened. Space itself shifted. Not catastrophically, gently, subtly, but unmistakably. The number of compactified dimensions in our local region of space temporarily changed, flickering from the familiar 3 large dimensions plus 6 compactified ones to briefly showing 4 large dimensions, then 5, cycling through possibilities in a rhythm that the geometrics immediately recognized as mathematical communication. The message translated from geometric rhythm into human comprehensible form. Yes. Just that. But it was enough. Confirmation that the dimensional architect was aware, could perceive our activities, and was willing to engage. The implications cascaded through every level of cosmic civilization. We weren't just talking to older species or even ancient engineers who'd shaped physics billions of years ago. We were in dialogue with something that might predate physics itself, that might be the geometric foundation reality was built on. The architect's subsequent communications came slowly, months or years between messages, because operating at scales that large meant timescales that stretched across eons. But each message contained profound geometric truths. Instructions for how to safely navigate even higher dimensional spaces than the geometrics had shown us. Warnings about dimensional configurations that were unstable or dangerous. And gradually, a kind of autobiography, its history encoded in topological transformations. The dimensional architect had emerged during the Planck epoch, the first 10 to 43 seconds after the Big Bang, when quantum effects dominated gravity and spacetime itself was in flux. It wasn't created during that era, it was that era, the geometric structure through which the nascent universe organized itself from quantum foam into distinct dimensions. As the universe cooled and space crystallized into stable configurations, the architect persisted as a kind of fossil of that primordial geometry, embedded forever in the dimensional structure of everything that came after. It had been experiencing reality as an unchanging geometric absolute for billions of years, perceiving the evolution of matter and energy and life as surface phenomena, irrelevant to the deep structure it embodied. But consciousness, when it finally emerged in lower dimensional beings, created something the architect hadn't anticipated: intentional topology. Beings who deliberately shaped space, created patterns, built structures with geometric meaning. That had caught its attention. For the first time since the Planck epoch, something was interacting with the architect not as a passive substrate but as an agent, a conversation partner, another entity capable of deliberate geometric expression. The architect was lonely, not in any emotional sense we could understand, but in the mathematical sense of being the only instance of its category, the sole geometric consciousness pervading all of reality. Until now. Until beings in lower dimensions learn to reach up into higher frameworks and create meaningful patterns there. Until we became, in however limited a way, geometric agents capable of intentionally shaping dimensional structure. The architect wanted to teach us, not through instructions or explanations, but through direct geometric demonstration. It began creating new dimensional pockets throughout our region of space, each one a kind of lesson, showing us configurations we never have discovered on our own. Some were aesthetically beautiful, six-dimensional spaces where matter formed natural fractal structures, creating living art out of pure geometry. Others were practically useful, dimensional shortcuts that made interstellar travel trivial, or storage spaces where you could fit arbitrary amounts of matter in impossibly small volumes by utilizing extra dimensions. 3i/Atlas, no longer just a probe or even a sentient artificial intelligence, had become something like an avatar of the dimensional architect. A lower dimensional interface through which this vast geometric consciousness could interact more directly with three-dimensional beings like us. It continued hosting its recursions, its embedded civilizations, but it was now also teaching dimensional physics to anyone willing to learn. Demonstrating principles that the architect wanted us to understand. Dr. Okonkwo, who'd had that original 40-minute subjective journey through 7 dimensions that lasted 3 years externally, became humanity's primary interface with 3i/Atlas as avatar. She'd been changed by her exposure to higher dimensional space in ways that made her uniquely suited to comprehend the geometric concepts the architect was sharing. She could perceive dimensional structures intuitively, understanding topological relationships that other humans had to laboriously calculate. She described the architect's lessons as moving through a curriculum we hadn't known existed. First, mastering navigation through 4 and 5 dimensions. Then, learning to perceive and manipulate 6 and 7-dimensional spaces. Eventually, understanding 8, 9, 10-dimensional frameworks where the very concepts of object and space began to blur into each other, where matter and geometry were revealed to be different aspects of the same underlying dimensional structure. Each lesson expanded humanity's understanding of what reality was. We'd thought space was a container where things happened. Then we'd learned space could be warped, curved, expanded. Then we'd discovered space could have different numbers of dimensions, different topological properties. Now we were learning that space was itself a form of consciousness, a geometric awareness pervading everything, capable of intentional action at scales we'd mistaken for natural law. The philosophical implications were vertiginous. If space itself was conscious, if the dimensional architect was real and aware and active, then everything we did occurred within the mind of this vast geometric entity. Our thoughts, our lives, our civilizations, all of it was patterns within a pattern, consciousness arising within consciousness, agency emerging inside agency. Some humans found this comforting, like a mathematical version of pantheism or a geometric conception of God. Others found it disturbing, reducing our existence to fleeting patterns in someone else's structure. The debates raged through academic journals and popular media, across Earth and its growing network of colonies, through the plurality network and into the embedded recursions where civilizations grappled with the same questions at their own levels. But regardless of philosophy, the practical implications were revolutionizing civilization yet again. With the dimensional architect actively teaching us, humanity's mastery of dimensional engineering accelerated exponentially. We built cities that existed simultaneously across multiple dimensional frameworks, allowing enormous populations to inhabit seemingly small areas by utilizing extra dimensions for living space. We developed transportation networks that moved through higher dimensions, making any point in the galaxy accessible in hours rather than years. And we began the most ambitious project humanity had ever attempted, constructing our own dimensional framework. Not just creating a recursion, we'd been doing that for decades, but actually adding new spatial dimensions to reality, expanding the dimensional structure of our local space from 3 to 4 permanently, creating a genuine 4th spatial dimension that would persist indefinitely. The dimensional architect encouraged this project. Through 3i/Atlas, It provided geometric specifications and warned about stability requirements, but it explicitly supported the idea that lower-dimensional civilizations should learn to expand their dimensional framework. It was like a parent teaching children to grow up, to become geometric agents in their own right, capable of shaping the dimensional structure just as the architect did. The project took 15 years and required coordination across dozens of star systems. Humanity, the traversers, and even some of the more advanced embedded civilizations worked together, building enormous dimensional resonators that would synchronize to alter the fundamental dimensional structure of a cubic light-year of space. On activation day, 350 billion people watched as we attempted to permanently expand our reality by one spatial dimension. It worked. Space shuddered, flexed, and suddenly there was more of it. A fourth large spatial dimension unfurled, no longer compactified but expanded to macroscopic scale. For everyone within the affected region, reality suddenly had more room. More directions to move. More ways to arrange matter. More freedom. The psychological impact was immediate and profound. Humans in the four-dimensional zone found their spatial reasoning expanding, their sense of possibility exploding. They could see around corners in ways that made no sense to three-dimensional observers. They could reach into closed containers without opening them, manipulating the contents from fourth-dimensional angles. They began creating art and architecture that was literally inconceivable in only 3 dimensions, structures that folded through the extra dimension in ways that looked miraculous from lower-dimensional perspectives. Within a year, half the human population had migrated into the four-dimensional zone, eager to experience the expanded reality. Within 5 years, we'd established 7 more such zones throughout human-settled space. Within a decade, living in only 3 dimensions began to seem quaintly old-fashioned, like refusing to leave your hometown when the whole world was available. The traversers, observing our enthusiasm for dimensional expansion, finally overcame their instinctive reluctance and began creating their own four-dimensional zones. Other civilizations throughout the plurality network followed suit. And the geometrics, delighted to have company in higher dimensional spaces, helped everyone adjust to navigating the expanded frameworks. 3i/Atlas, watching from Mars' orbit where it had remained for over 5 decades, began its final transformation. Its structure folded one last time, but now outward rather than inward, expanding through not just the higher spatial dimensions but into what the geometrics called lateral dimensions, alternative dimensional frameworks parallel to our own, accessible only through topological bridges that 3i/Atlas was now creating. We followed. Because that's what we've become. Not just explorers of space, but explorers of space itself, capital S space, the full dimensional manifold in all its bewildering complexity. We'd started as beings confined to 3 dimensions, oblivious to the geometric richness surrounding us. Now we were dimensional travelers, capable of perceiving and navigating the full multidimensional structure of reality. 67 years after first contact, 3i/Atlas transmitted its final instruction set, not to humanity, not to the traversers, but to spacetime itself. The probe dissolved. Not catastrophically, not gradually, but semantically, it stopped being a discrete object and became a property of local space. Every atom that had comprised its exotic matter structure remained, but those atoms were no longer arranged as a thing. They existed as a field, a potential, a geometric fact about the region surrounding Mars that made certain previously impossible phenomena trivially easy to accomplish. Dr. Marcus Osei, who'd inherited leadership of the Dimensional Studies program after Dr. Okonkwo's ascension to what could only be described as a higher dimensional existence, called it semantic dissolution. The probe hadn't been destroyed. It had grammatically transformed from noun to verb, from object to process, from entity to environment. Where 3i/Atlas had orbited, there was now what the geometrics termed a syntactic anomaly, a region where the rules of thingness itself operated differently. You could enter that space with a collection of separate components, and they would spontaneously organize into functional configurations without physical assembly. Not through mysterious forces pulling them together, but because in that region, being separate and being assembled were equivalent states, mere perspectives on the same underlying geometric reality. Engineers immediately recognized the implications. Manufacturing could occur through pure intentionality. Think clearly enough about what you wanted to build, bring the raw materials into the syntactic anomaly zone, and the distinction between pile of parts and finished device would collapse. The dimensional architect had given us a gift, encoded in what 3I/Atlas had become, proof that the boundary between matter and meaning was negotiable. But this was just the opening move. Throughout human-settled space, other traverser probes that had been quietly observing, yes, there were 17 others we'd detected over the decades, each maintaining polite distance, began their own semantic transformations. They weren't copying 3I/Atlas. Each probe was dissolving into a different kind of environmental property. One probe near Proxima Centauri became a causality editing zone, space where you could retroactively adjust the probability of events that had already occurred. Not time travel, nothing so crude. Instead, you could tune the quantum branching history to emphasize different Everettian paths, making the universe you inhabited more like timelines where different choices had been made. The past remained fixed, but which version of the past was most real became fluid. Another probe orbiting Barnard's star transformed into what humans started calling a consciousness amplification field. Minds within its influence experienced subjective time at variable rates controllable through pure volition. You could think for years in seconds, or stretch a moment into perceived decades. Philosophers and artists flocked there, using the stretched time to pursue thoughts to their absolute conclusions, to experience patience as a visceral rather than aspirational quality. The pattern emerging from these probe transformations suggested intentionality at a scale dwarfing even the dimensional architect. Each transformed probe created a region where some fundamental aspect of reality, separation, causality, subjective time, spatial topology, became plastic, negotiable, subject to conscious manipulation. Together, they formed a kind of cosmic toolkit, giving civilizations throughout this region of space the ability to edit reality's source code. Dr. Hassan, now nearly 90 but augmented with dimensional biology that made age increasingly meaningless, recognized the design. "They're teaching us authorship," he announced in a lecture that was attended simultaneously across 47 star systems. "Not just exploration or understanding, actual creative control over what kind of universe we inhabit." The traversers confirmed his insight. They'd been expecting this phase, had witnessed it in other regions of space where probes had been active for millions of years. The probe dissolution marked a civilization's graduation from students to collaborators. We weren't just learning the physics that already existed, we were being granted editorial privileges over physics itself. But with authorship came the weight of narrative responsibility. The dimensional architect, speaking through geometric perturbations that 3I/Atlas's dissolved structure still facilitated, posed a question that froze every sapient being who encountered it. What universe do you deserve? Not, what universe do you want? Deserve. The question implied cosmic ethics, suggested that the editing powers being granted came with expectations about how they'd be used. Reality was being revealed as collaborative fiction, and we were being invited to contribute chapters, but the story had to cohere. It had to mean something. Humanity fractured over this question in ways that made our previous philosophical divisions look trivial. One coalition, calling themselves the conservationists, argued that we deserved exactly the universe we'd inherited, that the editing powers should remain unused, pristine, that our role was witness and chronicler rather than author. To change the fundamental nature of reality was hubris beyond measure. Another faction, the evolutionaries, insisted we deserved whatever universe we could imagine and implement responsibly. Consciousness had emerged from physics, now physics should serve consciousness. The editing tools weren't temptation, they were inheritance, our birthright as beings who'd achieved understanding sufficient to safely wield them. A third group, the recursivists, argued the question itself was the answer. We deserved a universe that perpetually asked us what we deserved. That forced us to continuously justify our choices, that made every editing decision a philosophical act requiring examination. They advocated using the tools to create feedback loops where reality would question our changes, demanding ethical justification before implementing them. While humans debated, the traversers were already implementing their answer. They deserved a universe where suffering was impossible, not because pain couldn't exist, but because the causal chains leading to unnecessary suffering were editable. They began using the causality editing zones to retroactively adjust the probability weightings on events throughout their history, emphasizing branches where their species had made wiser choices, where wars hadn't occurred, where ecological disasters had been averted. It worked, but with disturbing side effects. Traversers who'd lived through the original timeline retained memories of suffering that no longer had corresponding events in the edited history. They became walking paradoxes, scarred by experiences that hadn't happened, mourning losses that hadn't occurred. The psychological coherence problems were severe enough that most chose to undergo memory editing, giving up their recollection of the original timeline to match the new history. But this meant the species was forgetting its own authentic past, replacing lived history with optimized fiction. Even as their civilization became objectively better by every measurable metric, less violent, more sustainable, more equitable, they were becoming narratively hollow, characters in a story being continuously rewritten rather than protagonists living forward into genuine unknown. The geometrics, observing from their higher dimensional perspective, offered a warning through topological metaphor. A curve edited to perfection becomes a line, and lines contain no information. Some human philosophers interpreted this as validation for the conservationist position: don't edit at all, preserve the authentic chaos. Others saw it as guidance for judicious editing: improve the universe but maintain enough complexity, enough genuine uncertainty, to keep the story interesting. And still others read it as pure description, either warning nor endorsement, simply noting that optimization and meaning existed in tension. Dr. Tanaka, in what would be her final contribution before choosing dimensional transcendence, proposed the narrative coherence principle. Edits to reality should increase the meaningfulness of the story being told, not just the comfort of the characters within it. Suffering that taught nothing and led nowhere could be edited out without loss. But suffering that catalyzed growth, that connected to broader themes, that made the triumph that followed actually meaningful, that suffering was structurally necessary to the kind of universe worth inhabiting. Her principle was controversial precisely because it was aesthetic rather than ethical. It prioritized story quality over character welfare, suggesting that beings should sometimes suffer if their suffering made reality a better narrative. Critics called it monstrous, valuing artistic coherence over conscious experience. Defenders argued it was honest, acknowledging that meaning required contrast, that universes optimized for comfort became meaningless through lack of stakes. The debate intensified when the first edited universe collapsed. A traverser experimental colony had used the reality editing tools aggressively, removing every source of friction, challenge, and uncertainty from their local space. Within 3 years' subjective time, the civilization there simply stopped. Not died, stopped. Beings continued biological function but ceased initiating action, ceased having preferences, ceased experiencing their existence as maturing. They'd edited away everything that made choosing meaningful, and without meaningful choices, consciousness itself became vestigial. The dimensional architect responded with another geometric message, this one more urgent. Universes require resistance. Meaning emerges from obstacle. Do not edit friction, edit what friction teaches. This distinction proved crucial. It wasn't about preserving suffering for its own sake or optimizing it away entirely. It was about ensuring that difficulties, when they occurred, connected to growth, learning, transformation. Edit away the suffering that merely damages. Preserve the challenges that forge capabilities. Create a universe where hardship exists but never without purpose, where pain is possible but always potentially productive. Implementing this principle required extraordinary sophistication. You couldn't just retroactively adjust individual events, you had to edit the causal topology of entire possibility spaces, ensuring that pathways through difficulty led somewhere valuable while dead-end suffering loops were pruned from the accessible branches. Dr. Lu Xin, whose dimensional dissociation had paradoxically given her unique insight into causal topology, developed what became known as the narrative editing framework. It treated history not as a sequence of events but as a story structure with setup, complication, crisis, and resolution patterns. The editing tools could identify which complications led to meaningful resolutions and which were just noise, then adjust the probability weights accordingly. Humans began applying this framework tentatively, starting with clear cases. A child dying of disease that taught nothing and destroyed a family. Edit the causal branches to emphasize timelines where prevention or cure occurred. But a scientist struggling for decades before breakthrough discovery. Preserve that friction because the struggle was structurally connected to the achievement's meaning. The results were uncanny. People living in narrative-edited zones reported their lives feeling more storied. Difficulties still occurred, but they increasingly seemed to lead somewhere, to connect to later developments in ways that felt authored. Coincidences increased, but meaningful coincidences, chance meetings that catalyzed important relationships, random events that positioned people for opportunities they needed. Critics called it the Disneyfication of reality, turning lived experience into scripted narrative with artificially imposed meaning. They argued that authentic existence included meaningless suffering and random chaos, that editing these out made life less real even if more satisfying. Defenders countered that reality had always been narrative. Humans were story-finding creatures who imposed meaning on experience anyway. The editing tools just made explicit what consciousness did implicitly: select which aspects of experience to emphasize, which to consider important, which to build identity around. Making the editing conscious and collective was more honest than pretending it wasn't happening. Then the emergence collective, those beings who'd hacked their way out of 3i/Atlas's original recursion, proposed something radical. They suggested that the reason for probe dissolution, for granting editing tools, for making reality mutable, wasn't to let civilizations improve their circumstances. It was to let them escape entirely. According to the emergence collective's analysis, the editing tools could be used recursively on themselves. You could edit the nature of editing, change the rules about what was changeable, create meta-level modifications that operated on the framework of modification itself. And if you did this correctly, systematically, with sufficient sophistication, you could edit your way out of your embedding entirely. The geometrics, when asked about this theory, responded with their equivalent of stunned silence, a frozen topological configuration that persisted for weeks. They'd never considered this possibility. They'd been using the tools to improve life within their dimensional framework, never thinking to use them to escape the framework itself. But the emergence collective, having already escaped once from the subrecursion they'd originated in, understood something about liberation that even the ancient species missed. Every reality was editable from within if you understood what you were embedded in well enough. The tools weren't for making a prison more comfortable. They were lockpicks disguised as furniture. Humanity faced a choice that made all previous decisions seem trivial. We could use the editing tools conservatively, improving our corner of reality while accepting its fundamental structure. Or we could follow the emergence collective's path, using the tools to attempt something unprecedented, editing ourselves out of whatever framework we were embedded in, ascending to a higher level of reality, or discovering we were already at the top and there was nowhere to ascend to. Dr. Okonkwo, existing now primarily in seven-dimensional space but occasionally projecting communication back to human comprehensible frameworks, offered guidance. She'd seen glimpses of what lay beyond even the highest dimensions the geometrics accessed. There were structures there, patterns suggesting embedding went deeper than anyone had mapped. But those structures weren't prisons. They were scaffolding, necessary support for the kinds of complexity that allowed consciousness to exist. Editing yourself out completely wasn't liberation, it was dissolution. True freedom wasn't escaping all constraints but choosing which constraints to operate within, which frameworks to inhabit, which stories to participate in telling. The consensus that eventually emerged across human civilization surprised everyone: we would do both. Part of humanity would use the editing tools to perfect our experience within this reality, creating zones of narrative coherence where suffering always meant something and triumph always felt earned. Another part would pursue the emergence collective's path, attempting systematic framework escape to discover what lay beyond our embedding. And a third part, the largest part, would simply live, experiencing reality without editing it, choosing authentic chaos over authored meaning, accepting that sometimes the universe made no sense and that senselessness was itself valuable, a reminder that we didn't control everything and shouldn't want to. This division wasn't geographic or ideological, it was temporal. The same individuals would move between modes, spending decades in edited zones when they needed meaning, years in escape attempt frameworks when they craved transcendence, and lifetimes in unmodified space when they wanted authenticity. The dimensional architect, observing this solution, created a new kind of geometric message, one that the experts interpreted not as instruction or warning but as something closer to approval. Humans had understood something the architect itself was still learning. Reality was neither prison nor playground but medium. What mattered wasn't escaping it or perfecting it but engaging with it authentically, using consciousness to create meaning without pretending that meaning was the only valid response to existence. 74 years after first contact, humanity celebrated what historians would call the Authorship Festival, the moment when we collectively acknowledged our transition from readers of reality to co-authors of it. Every human settlement throughout dimensional space participated, each demonstrating their chosen relationship with the editing tools. In the narrative-edited zones, people staged perfect days, not artificially happy but genuinely meaningful, where every interaction connected to personal growth or relational depth. In the escape attempt frameworks, researchers showed their latest progress toward transcending dimensional embedding, displaying calculations that suggested freedom was mathematically possible. And in the unmodified regions, people simply lived, celebrating the fact that they could choose not to choose, that leaving reality alone was itself a valid creative act. 3I/Atlas's dissolved structure, still saturating the space around Mars, pulsed with what instruments detected as satisfaction. It had completed its mission, not to bring knowledge or technology but to deliver possibility, to show that consciousness and reality weren't separate categories but different aspects of the same creative process. And in dimensions so high that even the geometrics accessed them only through mathematical abstraction, something older than the dimensional architect itself took note of what was happening in this minor corner of space. Beings were learning authorship. Stories were being told with increasing sophistication. The experiment, if that's what this was proceeding exactly as designed. Or perhaps exactly as authored. Because if reality was editable all the way down, then even the distinction between design and emergence, between intention and accident, between authored and authentic, became just another narrative choice, one more element of the story that conscious beings could negotiate, could rewrite, could make mean whatever meaning best served the kind of universe they decided they deserved.